Okay, so we're in chapter 3, section 1. We're going to be looking at lines and angles, and specifically, we're going to look at the definition of parallel lines. And the goal is to identify relationships between figures in space and angles formed by two lines and a transversal. And these are all the vocabulary words that we're going to be looking at. So starting off, the parallel lines are coplanar lines that do not intersect, and we use the symbol, the parallel, so it looks like this. So we would say it is parallel to. So AE is parallel to BF, and AD is parallel to BC. So if you can see that AE is parallel to BF. Now, a little bit more on the parallel lines. Down here at the bottom, it says to use arrows to show that AE is parallel to BF. And so you see these little tick marks right here. That's what indicates parallel lines. So the next definition is the skew lines. The skew lines are non-coplanar, and they are not parallel, and they do not intersect. So not parallel and don't intersect. So if we were looking at this, that AB and CG are skewed. They are not parallel and they do not intersect. Another example that we can look at other than what's listed is EF. So we have EF, then we would say that CG, those lines are skew lines because they are not parallel and they do not intersect. Parallel planes are planes that do not intersect. They are planes that are parallel. So picture a box. When you pick up the box at each end, those planes are parallel with each other. So here's an example of the planes that are parallel. This plane that they have indicated here, that's parallel planes right there. Okay? So in the figure, assume that lines and planes that appear to be parallel are parallel. So we're going to identify non-intersecting lines and planes. That's what we're working on here. What are the two pairs of parallel planes? Well, there are several of them. The first one would be the ones that are like on the side here, where we have ABFE and CDGH. Those are parallel planes, okay? So let's see what we have right here. So we have ABCD. So that's going to be the top of the box. And EFGH, that's the bottom of the box. Those planes are parallel. And of course, the ones that I've identified on the side is DCG. So this is on the side here. And ABF. Those two planes are parallel. Now we're looking at something that's a little bit different. It says, what are two segments parallel to the plane BCGF? So we're looking at lines that are parallel to the plane. So if we look at BCGF, this is like in the back part of the box. Picture it being at the very back. And so what it's saying here is the two segments that are parallel to it is AD, so this is the front edge right here, and DH. Okay, so I want you to picture that AD is parallel to the part of the plane of BC, and DH is parallel to the part of the plane of CG. Okay, and so even though it's asking the segments that are parallel to the plane, you look at parts of the edge of the plane that you could see. All right, in the figure, assume that lines and planes that appear to be parallel are parallel. What segments are parallel to AB? So let me use a different color here. We're looking specifically at AB right here, and we're trying to figure out what lines are parallel to this. So the first one, if we look, is DC. So we have DC right here. That's the one that's parallel to AB. The next one is EF, and EF is down here on the bottom, and it's also parallel to AB. And then of course we have HG, which is also parallel to AB. And so that's what our final answer is that EF, DC, and HG are all parallel to line segment AB. So now we're looking at which segments are skew to CD. So I'm going to use a different color again. Here's CD right here. And so we're looking at which segments are skew. So BF is skew to CD. Remember, they don't intersect and they are not parallel. So that's one possibility. AE skews to CD. So this one is also skew to CD. EH is also skew. So this one is also skew. It does not intersect CD, nor is it parallel. And then FG is also skew. So it's right here. So one thing to look at is that if they are not parallel and they do not intersect those line segment, that is the definition of skew lines. So I want you to see if you can look at this one and figure out which segments are parallel to AD. So if you want to go ahead and pause this and then see if you have the correct answer. So I hope you're doing okay with this. So the first thing is that we would say that EH is parallel to AD, which is right here. And BC is also parallel to AD, which is right here. And FG is parallel to AD. And just as a reminder that whenever you have parallel lines, you need to show the arrows that these are parallel. That's what it looks like. All right, so transversal. That's one of the definitions. So when a line intersects two or more lines, the angle formed at the intersection points creates special angle pairs. And so that line that intersects two or more lines at the distinct point is what is called the transversal. So this line right here is what we call the transversal. Line T is the transversal. And so if you look at these two lines here, you're looking at the interior area where it's between the two lines, and you're looking at the exterior, which is outside the two lines. So we're going to be looking at these different types of angles. So alternate interior angles are non-adjacent interior angles that lie on the opposite side of the transversal. So when it says alternate, just think about you're going back and forth. So here is your transversal right here. This is your transversal. And so if you would see alternate interior is 4 and 6. Those are alternate interior angles. Another example of alternate interior angles is 5 and 3. Those are alternate interior angles. The next definition is the same side interior angles. They are interior angles that lie on the same side as their transversal. Now remember, the alternate interior is between the two lines and it's going back and forth. Well, on the same side interior, here's our transversal right here again. And so we have the same side interior. It is also called consecutive angles. We're going to hear those terms, both of those terms. Another example of consecutive angles is also 5 and angle 4. Corresponding angles. Corresponding angles lie on the same side of the transversal and in corresponding position. When it says corresponding position, it's like it's in the same spot. So here's my transversal again right here, and the corresponding is where it just kind of, see how this one is sitting on top of the one of the lines, line L. Well, the other line, it's still sitting on top of it. That's corresponding. That's what we call corresponding. So another example of corresponding is 2 and 6. Can you see any other corresponding where they're in the same spot on each of those lines? Well, we have 4 and 8. Three and 7. Those are all example of corresponding angles. Alternate exterior are non-adjacent exterior angles that lie on the opposite side of the transversal. So remember that the alternate interior is on the inside. Exterior, it's on the outside. And it's alternating, but it's alternating outside these two lines. So here is an example of alternate exterior. So 1 and 7 are alternate exterior. Or 2 and 8. Those are alternate exterior angles. So let's go ahead and let's practice these. So which pair of alternate interior, which is a pair of alternate interior angles? And so just remember that this is our transversal right here. And when it says interior, we're talking about inside between the two lines here. Okay, so alternate, that means that it's going back and forth. So it's going along the transversal and it's alternating there. So the alternate would be 2, angle 2, and angle 6, angle 7, and angle 3. So you've got to only pair up the angles, okay? So angle 7 and angle 3 are only the alternate interior angles, okay? So which is the pair of the same side interior? So we're still looking at the interior, and I've got the transversal pointed right there. And so we have angle 2 and angle 3 and angle 7 and angle 6. So now we're going to be looking at corresponding angles. Now the corresponding angles is on the same side as the transversal, but it's in the corresponding spot. So here I pointed out the transversal, and so on one side here, this is on to the left of one of the lines. So on this one, see how it's on the same side as the transversal, but one is on the outside of the two lines and the other one's on the inside. So we would say that 8, angle 8, and angle 6 are corresponding angles. We have 1 and 3, that's corresponding angles. So angle 1 and angle 3 are corresponding angles. I erased these so that you could see how they are paired up. So if we go like to the right hand side, same side as the transversal, then you'll see that 2 and 4 are corresponding. So angle 2 and angle 4. And so we have 7 and 5. So angle 7 and angle 5. So now let's look at alternate exterior. So it's going to alternate along the transversal, but it's going to be on the exterior. So this part right here is the exterior, and over here is the exterior. And so we're going to alternate. So we have 1 and 5. See how it's alternating on the outside. So angle 1 and angle 5. We also have 8 and 4. So angle 8 and angle 4. Those are alternate exterior angles. So the photo below shows the Royal Ontario Museum in Toronto, Canada. Are angles 2 and 4 alternate interior angles, same side interior angles, corresponding angles, or alternate exterior? So let's look at 2 and 4. So here is 2 and here's 4. You see the two lines? Remember, the transversal is that line that crosses over two of them. And so you can see that this is the interior region right here, and it's alternating along the transversal. So it's called the alternate interior angle. So this is the exit ticket that I would like for you to do. If you can put it on a separate sheet of paper, make sure your name is on it, call it exit ticket. It is for Chapter 3, Section 1. And make sure that you name a pair of alternate exterior angles and a pair of corresponding angles.